Okay, so this is my response to the 108 questions. My name is David Lee. So we'll first start with the prompt. So it says, we conducted a randomized control trial where some centers use an expertise-based randomized control trial design, while others use a traditional randomized control trial design. So basically, if you envision it, we can have center A here using a traditional RCT, while center B uses an expertise RCT. At the end of the study, we pulled the results to arrive at a more precise estimate of the treatment effect. Would be a reason we should not combine the results. So there are actually numerous reasons why we shouldn't be combining the results of an expertise randomized control trial and a traditional randomized control trial. The first being is our research question is now different. An expertise randomized control trial, our research question needs to have a qualifier in it. This could be, for example, in the heads of an expert, is treatment A better than treatment B? Next, our methods have also changed. Our intervention in an expertise randomized control trial is now done by someone who is an expert in that intervention. Therefore, our results are likely to change or be different because in a traditional randomized control trial, we cannot guarantee that the person delivering the intervention is always an expert. Finally, the applicability of the results or the external validity is also different. If an expertise randomized control trial shows that one treatment of surgery is superior to another treatment of surgery, it only means that this one procedure is superior to another only if the surgeons acquire the same skill set and expertise as the surgeons who participated in the expertise randomized control trial to begin with. This does not mean that they can expect better results in general. Next, our expertise randomized control trial is also not subject to differential expertise bias, a learning curve, preference by clinician, and it also has reduced likelihood of contamination. So what would be a reason that we could combine these results? Often in the area of clinical research, some of the trials may be too small to be conclusive on their own. Investigators often feel compelled to review and compile data on similar trials with similar methods to obtain more precise estimates and increase power of an intervention effect by increasing sample size. If the trial and center is using a traditional randomized control trial and expertise randomized control trial were both conducted with very similar methods, we could probably pool the results. These specific circumstances could be if we reduce the learning curve, such as by implementing a simple intervention like sewing stitches, or if we use a farm-based intervention, which we could establish more clinical equipoise, or if we establish a method to prevent differential expertise bias, such as ensuring that we have a certain number of expertise per particular intervention, we could probably pool the results since we have similar methods. The last question asks, can you think of a method we could use to test whether it's reasonable to combine the results? So currently there is no known method out there that specifically looks at if we can combine the results of a traditional randomized control trial and an expertise randomized control trial. However, we could use some statistical methods that are currently out there. In the meta-analysis, the I-squared method developed by the Cochrane Reviews is used in order to tell the heterogeneity or the differences between two methods of different studies. This is also known as methodological diversity. The equation for the I-squared method is shown right here. If we treated the results from the traditional randomized control trial and the expertise randomized control trial as coming from different studies, we could see if it is reasonable to combine the results using this I-squared tool. The Q refers to a chi-squared statistic, while the DF refers to the degrees of freedom. The degrees of freedom is dependent on the sample size and increases with sample size. The Q, or the chi-squared statistic, compares whether the differences of observed characteristics are compatible with chance. A low p-value between the studies translates to a high chi-square statistic. Therefore, if we have a high chi-square statistic compared to the degrees of freedom, this would provide evidence for heterogeneity. The higher the I-value, the more likely there is heterogeneity between the two studies, or there more likely a difference between the methods employed by two studies. The I-squared values can be translated using this table.